Hello students, welcome to the Bridge course of Physics, Excellence PU College, Karkala. Today I am going to do the chapter Mechanical Properties of Solids. In our daily life, we come across the solid objects such as metal rods, wooden beams, rubber bands and buildings. When the force is exerted on these objects, the shape or size of these objects may change, right? Yes, some materials returns to their original shape or size after removal of the force. Some materials do not regain its original shape or size after removal of the external force. Okay, this behavior of the materials under the action of external forces is studied in this chapter. In the chapter Mechanical Properties of Solids. Mechanical properties of solids. Okay, this chapter helps us to understand the concept or behavior of the materials under compression, tension and the concept of plasticity, elasticity and the laws, important laws like Hooke's law and the properties such as Young's modulus, shear modulus, bulk modulus. Okay, and this chapter or understanding this chapter is essential in the fields of engineering, construction and material science. Okay, so first we will learn about the concept that is elasticity. Okay, first concept, elasticity. Elasticity. What is elasticity? Elasticity, it is the property of the material to regain its original shape or size after the removal of external force. What is elasticity? It is the property of the body due to which it regains its original shape or size after removal of external force. Example yavudu kodbodu? A rubber band. When you stretch it, when you stretch the rubber band, what happens? Its length increases, stretch agutte. When you remove the external force, remove madidaga adu enagutte? Original shape ge barutte, right? It returns to the original shape. Okay, elasticity is the property of the material due to which it regains its original shape, regains its original shape and size, shape or size after removal of external force. Okay, and what is elastic body? Elastic body, what it may be? So the body which possesses the property of elasticity, the body which possesses the property of elasticity are called elastic bodies. Okay, next, plasticity. What is plasticity? Okay, you know that what is elasticity? What is plasticity? It is the property of the body due to which it does not regain its shape or size after removal of external force. What is plasticity? It does not regain its original shape, does not regain its original shape or size, original shape or size after removal of external force, right? Plasticity elli nodbodu? Clay modeling alli, clay modeling. Okay, when you make an image, ಯಾವುದೋ ಒಂದು ಇಮೇಜ್ ಮಾಡಿದ್ದೀರಾ ಕ್ಲೇ ಮಾಡಲಿಂಗ್ ಅಲ್ಲಿ, ಸೊ ಅದಕ್ಕೆ ಒಂದು ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡಿ. ವೆನ್ ಯು ಅಪ್ಲೈ ದ ಫೋರ್ಸ್ ಇಟ್ಸ್ shape changes. Shape changes. When you remove the force, ಈಗ force remove ಮಾಡಿ, so it regains to its original shape? No. Whether it regains? No. Why? It is has the property of plasticity. Plasticity is the property of the body due to which it does not regain its original shape or size after removal of the external force. Clear? Next, plastic body. What is plastic body? What is plastic body? Yes, plastic body, the body which possesses the property of plasticity. The body which possesses the property of plasticity are called as plastic body. For example, clay. Example, clay. Okay, when you change the shape, it does not regain its original shape. Okay, this is about elasticity and plasticity. What is elasticity? Property of the body to regain its original shape and size after removal of external force. Plasticity is the property of the body due to which it does not regain its original shape or size after removal of external force. Okay, clear? Yes. Next, stress. Next concept, stress. What is stress? Stress is the internal restoring force per unit area. What is stress? It is the internal restoring force per unit area. Okay, so you know that you can observe, you can see the stress in elastic bodies. Okay, ಅದನ್ನ observe, ಎಲ್ಲಿ observe ಮಾಡಬಹುದು? elastic bodies ಅಲ್ಲಿ ಈಸಿಯಾಗಿ observe ಮಾಡಬಹುದು stress ಅನ್ನ. So it is the internal restoring force per unit area. So when you stretch the rubber band, so force is applied, deformed force ಅಂತದನ್ನ ಕರೆಯುವ. when you remove the force ಅನ್ನ remove ಮಾಡಿ, so it regains to its original shape. When you stretch the rubber band, it is the original length of the rubber band. When you stretch it, so its length increases. Okay, ಈಗ force remove ಮಾಡಿ, again it comes to original shape ಗೆ ಬರುತ್ತೆ. ಹೌದಾ? ಅದು ಹೇಗೆ ಬಂತು original shape ಗೆ? So stretch ಆದದ್ದು due to the deforming force. It is stretched due to deforming force, external force. So it again comes to its original shape due to this stress or restoring force. Okay, idli ಯಾವ force apply ಮಾಡಿದ್ದು? deforming force. deforming ಅಂದ್ರೆ, deformation ಅಂದ್ರೆ ಏನು? deformation means change in the shape or size of the object. ಈಗ ಒಂದು shape ಅಲ್ಲಿ ಇದೆ ball, it is in the round shape. ಸೊ ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡಿದ್ದೇನೆ, ಅದರ ಶೇಪ್ ಚೇಂಜ್ ಆಗಿದೆ. ಬಾಲ್ ಇದ್ದು ಶೇಪ್ ಏನಾಗಿದೆ? ಚೇಂಜ್ ಆಗಿದೆ. ವೆನ್ ಯು ಅಪ್ಲೈ ದ ಫೋರ್ಸ್, ಸೊ ಇಟ್ ಈಸ್ ಡಿಫಾರ್ಮ್ಡ್. ಇಟ್ಸ್ ಶೇಪ್ ಈಸ್ ಚೇಂಜ್ಡ್. ಸೊ ಇದು ಹೇಗೆ ಡಿಫಾರ್ಮ್ ಆಗಿತ್ತು? ಡ್ಯೂ ಟು ದ ಫೋರ್ಸ್. ಸೊ ದಿಸ್ ಫೋರ್ಸ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಡಿಫಾರ್ಮಿಂಗ್ ಫೋರ್ಸ್. ಓಕೆ, ಎಸ್, deforming force. So when you apply deforming force, the rubber band stretches. So when you remove this force, so rubber band comes to its original shape. How? Due to this internal restoring force. See, this is nothing but stress. Stress is the internal restoring force per unit area. So when you stretch the rubber band, the internal restoring force is developed inside the body. Due to this restoring force, the object comes to its original shape. Okay, so this restoring force or stress is nothing but restoring force is equal in magnitude and opposite in the direction of deforming force. Okay, it is equal in magnitude, and opposite in direction. Note, opposite in direction of deforming force. It is equal in magnitude. Andre, so when you stretch slightly, rubber band anna slight ಆಗಿ ಸ್ಟ್ರೆಚ್ ಮಾಡಿ, ಸೊ ಅದು ಅಷ್ಟೇ ಸ್ಲೋ ಆಗಿ ಅದು ಒರಿಜಿನಲ್ ಶೇಪ್ಗೆ ಬರುತ್ತೆ. ಸೊ ಅದೇ ನೀವು ಲಾರ್ಜ್ ಸ್ಟ್ರೆಚ್ ಮಾಡಿದರೆ, ಅದನ್ನು ತುಂಬ ಸ್ಟ್ರೆಚ್ ಮಾಡಿದರೆ, ಸೊ ಇಟ್ ಕಮ್ಸ್ ಕ್ವಿಕ್ಲಿ. ಸೊ ಅದೇ ವಿತ್ ಈಕ್ವಲ್ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್, ಫೋರ್ಸ್ ಈಸ್ ಈಕ್ವಲ್. ಓಕೆ, ರಿಸ್ಟೋರಿಂಗ್ ಫೋರ್ಸ್ ಈಸ್ ಈಕ್ವಲ್ ಇನ್ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್, opposite in direction ಅಂದರೆ, ಸೊ ಹಿಯರ್ ಸಿ ಸ್ಟ್ರೆಚ್ ಮಾಡಿದ್ದು ಫೋರ್ಸು ಯಾವ ಡೈರೆಕ್ಷನ್, ಈ ಡೈರೆಕ್ಷನ್. ಓಕೆ, ಸ್ಟ್ರೆಚ್ ಡಿಫಾರ್ಮಿಂಗ್ ಫೋರ್ಸ್ ಇಸ್ ಅಪ್ಲೈಡ್ ಇನ್ ದಿಸ್ ಡೈರೆಕ್ಷನ್. ರಿಸ್ಟೋರಿಂಗ್ ಫೋರ್ಸ್ ಯಾವ ಡೈರೆಕ್ಷನ್, ಅಗೇನ್ rubber band comes to its original shape in this direction. So the restoring force is in this direction. Okay, so the restoring force is equal in magnitude and opposite in the direction of deforming force. Clear? Stress, so when the external force is applied, stress is developed inside the body. When the external force is applied, it changes its shape. Okay, due to this, stress is developed inside the body. Due to this stress, the object comes to its original shape or size. It regains its original shape or size. Clear? Yes. Stress. Mathematical form. If F is the force applied to the body having unit area of cross section A. Okay, if F is the force acting on the body having the area of cross section A, area of cross section A, then stress developed inside the body is force by area. Yes, force per unit area. So it is the internal restoring force per unit area. ಓಕೆ, ಸೊ ಎಷ್ಟು ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡ್ತೇವೆ, ಸೊ ಸ್ಟ್ರೆಸ್ ಎಷ್ಟು ಕ್ರಿಯೇಟ್ ಆಗುತ್ತೆ. ಸೊ ಸ್ಟ್ರೆಸ್ ಇಸ್ ದ ಇಂಟರ್ನಲ್ ರಿಸ್ಟೋರಿಂಗ್ ಫೋರ್ಸ್ ಪರ್ ಯೂನಿಟ್ ಏರಿಯಾ. ಓಕೆ, ಸ್ಟ್ರೆಸ್ ಈಸ್ ಈಕ್ವಲ್ ಟು ಎಫ್ ಬೈ ಎ. ಯೂನಿಟ್ ಆಫ್ ಸ್ಟ್ರೆಸ್ ಇಸ್, ಓಕೆ, ಯೂನಿಟ್ ಯಾವುದು, ಎಫ್ ನ್ಯೂಟನ್, ಫೋರ್ಸ್ ಇಸ್ ನ್ಯೂಟನ್, ಏರಿಯಾ ಮೀಟರ್ ಸ್ಕ್ವೇರ್, Newton per meter square. Okay, unit of stress is Newton per meter square or Pascal. So one more unit yavadu, Pascal. Okay, yes. And what is the dimensional formula? Dimension of stress, dimensional formula apply ಮಾಡಿ. Force iddu dimensional formula M L T minus 2. Yes. Area L square. Yes. So the dimension of stress is M minus 2. This become plus 2 becomes minus 2 minus 1. M L minus 1 T minus 2. Okay. Here L2 L1 becomes minus 1. Minus 1 plus minus 2 plus 1 becomes minus 1. Okay, this is the formula of dimension of stress. Its unit is Newton per meter square. Clear? Yes. Okay, there are 3 types of stress. Stress alli eshtu type ide? 3 type. There are 3 types of stress. ಯಾವುದೆಲ್ಲ 3 types of stress? 1. Longitudinal stress. 2. sharing stress, sharing or tangential stress. Tangential stress. What are the three types? Longitudinal stress, two, sharing or tangential stress, third one, volume or bulk or hydraulic stress. Hydraulic stress. Okay, these are the three types of stress. Yaudella? Longitudinal stress, sharing or tangential stress, third one, volume stress. What is this longitudinal stress means? Longitudinal stress. Longitudinal stress. So, longitudinal stress. So, when the deforming force is applied perpendicular to the surface of the body to change its length, then the restoring force per unit area is called longitudinal stress. Okay, it is, for example, take a body. Okay, longitudinal stress andre enu? It is the when the deforming force, if the deforming force is applied perpendicular, if the deforming force is applied perpendicular to the surface of the body, to the surface of the body to change its length, then the restoring force per unit area is called longitudinal stress. Longitudinal stress. So, this is the object, perpendicularly deforming force apply madi. So, when the force is applied perpendicular to the object, perpendicular to the surface of the body. So, here like this, to change its length, then the restoring force per unit area is called longitudinal stress. Okay, what is longitudinal stress? If the deforming force is applied perpendicular to the surface of the body to change its length change ಆಗುತ್ತೆ, compress ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ, its length decreases. When you stretch, its length increases. The force is applied perpendicular to the surface of the body to change its length, then the restoring force per unit area. So, force apply ಮಾಡುವಾಗ ಬಾಡಿಯಲ್ಲಿ ಡೆವಲಪ್ ಆದ force, stress. Okay, the restoring force developed inside the body is called as longitudinal stress. There are the longitudinal stress classified into two types. Okay, there are two types of longitudinal stress. Okay, two types. So, first one, tensile stress. So, tensile stress, if the deforming force states that if deforming force is applied perpendicular to the surface of the body, to increase its length, then the restoring force per unit area is called what? Tensile stress. Easy, right? Tensile stress. Okay, what is tensile stress? Same definition, longitudinal stress definition. if deforming force is applied perpendicular to the surface of the body to increase its length, then the restoring force per unit area is called tensile stress. Clear? So note here, if the body, consider this is the body, deforming force is applied perpendicular. The force is applied perpendicular to the surface of the body to increase its length. Length increase ಮಾಡಬೇಕಾದ್ರೆ, so force is outward. We have to pull, right? We have to pull the body. So force is applied perpendicular to the body to increase its length. Then the restoring force per unit area is called tensile stress. Tensile stress. Okay. This is the object body. When you apply the force perpendicular agi, force apply ಮಾಡಿ to increase ಮಾಡಿ ಅದನ್ನು, ಆ ಬಾಡಿದು ಲೆಂತ್ ಏನು ಮಾಡಿ increase ಮಾಡಿ, stretch ಮಾಡಿ from both the direction. Now the length of the body increased. Length of the body ಏನಾಯಿತು? Increased. Right? Yes. Right? It is stretched. It is elastic body. So it is stretched. Okay? And when you remove the force, ಈಗ stretch ಮಾಡಿದಿರ, force ಅನ್ನು ಬಿಟ್ಟಾಗ, when you remove the force, what happens? It comes to its original shape, original length, right? When you remove this force, when you remove this external force, it comes to its original length. So ಹಾಗಾದ್ರೆ ಅದು ಒರಿಜಿನಲ್ ಲೆಂತ್ ಬರಬೇಕಾದ್ರೆ the stress is developed inside the body when the deforming force is applied, right? So if the deforming force is applied perpendicular to the surface of the body to increase its length, then the restoring force per unit area, the force developed inside the body when we stretch, the force developed inside the body is called as what? Tensile stress. Okay, this is called as tensile stress. Okay, due to this tensile stress, the body comes to its original shape. Clear? Yes. Next, second type. This is the first type of what? Longitudinal stress. Next, second type. Compressive stress. Tensile stress, compressive stress. So name alli gottagutte. Okay, compressive stress, it is the, if the deforming force is applied, if deforming force is applied perpendicular to the body, right? Perpendicular to the surface of the body, compressive, to decrease its length, then the restoring force per unit area is called what? Compressive stress. Okay, compressive stress. Okay, what is compressive stress? If the deforming force is applied perpendicular to the surface of the body to decrease its length, then the restoring force per unit area is called compressive stress. Okay, example. So see, this is the length of the body. Okay, initial length of the original size of the body. Now the deforming force is applied perpendicular to the body to decrease its length. Okay, compressive. In this case, the deforming force is applied perpendicular to the surface of the body to decrease its length. Then the restoring force per unit area is called compressive stress. When you compress it, what happens? Its size or length decreases, right? So due to this deforming force, its size decreases, compresses. When you remove this deforming force, what happens? It comes to its original length. It comes to its original length. Okay, how it comes to its original length? Due to this compressive stress created inside the body. Okay, when you apply the force, deforming force perpendicular to the surface of the body, the restoring force developed per unit area, okay, developed per unit area is called what? Compressive stress. Compressive stress. Okay, compressive stress. Clear? What is stress? It is the restoring force per unit area. ಅದೇನಾಗುತ್ತೆ? Restore ಮಾಡುತ್ತೆ. It is equal in magnitude and opposite in the direction of deforming force. Okay, in this case deforming force is e direction, so restoring force in this direction. Okay, e direction, deforming force again ಅದು original shape ಗೆ ಬರಲಿಕ್ಕೆ ಟ್ರೈ ಮಾಡುತ್ತೆ. So restoring force is in this direction. Clear? ಈ ಕೇಸಲ್ಲಿ, previous ಕೇಸಲ್ಲಿ deforming force is in this direction, restoring force is in this direction. Okay, so we are stretching the body. Okay, stretching the body, but ಅದೇನಾಗುತ್ತೆ? stretch ಆದರೂ initial position ಬರಲಿಕ್ಕೆ ಟ್ರೈ ಮಾಡಿಸಿ. The internal restoring force per unit area is called the stress. Okay, this is about the longitudinal stress. Longitudinal stress is when if the deforming force is applied perpendicular to the surface of the body to change its length, longitudinal, change its length, then the restoring force per unit area is called longitudinal stress. Clear? Yes, there are two types of longitudinal stress, tensile stress and compressive stress. Tensile stress means if the deforming force is applied perpendicular to the surface of the body to increase its length, then the restoring force per unit area is called tensile stress. What is compressive stress? If the deforming force is applied perpendicular to the body to decrease its length, then the restoring force per unit area is called compressive stress. Okay, next which type? Longitudinal stress ಆಯಿತು. Next second type, shearing or tangential stress. Okay, shearing or tangential stress. Next type, shearing or tangential stress. Okay, so if the deforming force is applied parallel to the surface of the body to change its shape, okay, then the restoring force per unit area is called shearing or tangential stress. Okay, shearing or tangential stress. Okay, what is? If the deforming force is applied, deforming force is applied, here force is applied parallel to the, parallel to the surface of the body, to change its shape, then the restoring force per unit area, then restoring force per unit area is called what? Shearing or tangential stress. Shearing or tangential stress. Okay, what is shearing or tangential stress? Same way longitudinal stress. Okay, in that case force is applied perpendicular, in this case force is applied parallel. In this case of shearing stress, if the deforming force is applied parallel to the surface of the body to change its length, to change its shape, to change its shape, parallel to the surface of the body to change its shape, then the restoring force per unit area is called shearing or tangential stress. Okay, for example, okay, when the book placed on the table, okay, when you push it sideways, okay, sideways ಅಲ್ಲಿ ಒಂದು ಸರ್ಫೇಸ್ ಅನ್ನು ಅಪ್ಪರ್ ಸರ್ಫೇಸ್ ಅನ್ನು ಮಾತ್ರ ಪುಷ್ ಮಾಡಿ, ಓಕೆ, ವೆನ್ ಯು ಪುಷ್ ದ ಅಪ್ಪರ್ ಸರ್ಫೇಸ್ sideways, its shape changes, right? So initially the shape of the book is like this. Okay, book is placed on the table. Okay, book is placed on the table. So bottom surface ಹಾಗೆ ಇಲ್ಲಿ bottom surface stiff ಆಗಿರುತ್ತೆ. So when you push the upper surface of the book, so the ಏನಾಗುತ್ತೆ, its shape changes when we apply the force parallel to the surface of the body. Its shape changes. Okay, it is initially in the shape of what? Rectangle. Okay, and now it is in the shape parallelogram, nearly equal to parallelogram shape. So now the shape is changed. How? We are applying the force parallelly, okay, parallel to the surface of the body. It's to change its shape, then the restoring force per unit area is called shearing or tangential stress. So same way, when we remove the force, it comes to its original position, right? When you, or example, elastic body, just imagine when you apply force in the parallel direction and remove the force, it comes to its original position. So how it comes to its original position? Due to the stress developed inside the body, and this stress is called as what? Shearing stress or tangential stress. Why? In the case of change in its shape, we consider it as a tangential or shearing stress. Okay, what is shearing or tangential stress? If the deforming force is applied parallel to the surface of the body to change its shape, then the restoring force per unit area is called tangential or shearing stress. Okay, here relative displacement between the two surfaces, then there is a relative displacement between the bottom surface and upper surface. Okay, there is a change in the shape. This is called shearing or tangential stress. Okay, next, what is the third type of stress? Volume stress. Volume stress or bulk stress or hydraulic stress, ಹೇಗೆ ಬೇಕಾದರೂ ಹೇಳ್ಬೋದು. ಓಕೆ, ಹೈಡ್ರಾಲಿಕ್ ಸ್ಟ್ರೆಸ್, volume stress, bulk stress or hydraulic stress. What is volume stress means? Yes, okay, if the deforming force compresses the body uniformly from all the sides, then the restoring force per unit area is called volume stress. Okay, if the deforming force compresses the body uniformly from all the sides, then the restoring force per unit area is called restoring force per unit area is called what? Hydraulic stress or volume stress. Okay, for example, a ball a rubber ball in the underwater. Okay, consider a rubber ball in the underwater. What happens? The water pushes the ball in all the sides, from all the directions. Okay, from the all the direction. Okay, deforming force ಯಾವ direction apply ಆಗ್ತಿದೆ? ಎಲ್ಲ direction ಇಂದ, from the all the directions. So the ball compresses slightly. The ball compresses slightly, right? The ball compresses slightly. So again adra force tegdre enagutte, when the force is removed it comes to original. So the stress developed inside the body, this stress is called what? Volume stress. Volume stress. What is volume stress? If the deforming force compresses the body uniformly from all the sides, then the restoring force per unit area is called volume stress. Volume stress. Example, a rubber ball is in the underwater. The water pushes the ball uniformly from all the direction. So the ball compresses slightly it compresses. Then the restoring force developed inside the body, inside the ball, is called as volume stress or hydraulic stress or bulk stress. Why it is called as volume stress? Here the volume changes, volume of the ball or body changes, volume changes, but shape remains same. Shape ade, ಈಗ ball the volume change ಆಗ್ಬೋದು, ಇಷ್ಟು size ಇದ್ದ ball ಈ size ಗೆ ಬರ್ಬೋದು, right? It comes to this size, but its shape remains same. Its shape remains same, only change in the volume, only change in the volume. So that's why it is called as volume stress. Okay, clear? In the volume stress, only change in the volume, not in the shape of the body. Okay, what is stress? It is the internal restoring force per unit area. In that, longitudinal stress, shearing stress and volume stress. Longitudinal stress, if the force is applied perpendicular to the body to change its length, then the restoring force per unit area is called longitudinal stress. Shearing stress, if the deforming force is applied parallel to the surface of the body to change their shape, change its shape, then the restoring force per unit area is called shearing stress or tangential stress. Volume or bulk stress, it is when the deforming force compresses the body uniformly from all the directions, all the sides, then the restoring force per unit area is called volume stress. Volume stress. Clear? Yes. Okay. Okay. Stress tells us how much the deforming force is behind it. Okay. Stress tells the force. Next comes to the concept that is strain. Strain. Okay. What is strain? Strain, you know that. That is, strain is the change in the shape or size of the body due to the deforming force is called as strain. Okay, what is strain? It is the change in the shape or size of the body due to the deforming force is called strain, and it is also known as and it is also defined as the ratio of change in dimension to the original dimension. Change in dimension to the original dimension. Original dimension. Okay. What is strain? Strain is the ratio of change in dimension to original dimension. What is the unit of strain? It has no unit. Strain has no unit. It is dimensionless. It is dimensionless. Okay. It is the change in the shape or size of the body due to the deforming force is called strain. or the ratio of change in the dimension to original dimension. Okay, strain tells how much deformation occurs. Strain tells us how much deformation occurs. Okay, for example, yaudu, consider if the rubber band initially has the length 10 centimeter. Okay, strain ಅಂದರೆ ಎಷ್ಟು ಚೇಂಜ್ ಆಗಿದೆ ಬಾಡಿಯಲ್ಲಿ. ಓಕೆ, ಎಷ್ಟು ಡಿಫಾರ್ಮೇಷನ್ ಆಗಿದೆ ಅಂತ ನೋಡೋದು. ಓಕೆ, the rubber band initially has the length 10 centimeter. Okay, when you stretch ಮಾಡಿದಾಗ, so its length becomes, imagine it is 12 centimeter. 12 centimeter. Okay, 12 centimeter. So change in the length is how much? 2 centimeter. 2, strain is 2 centimeter. Change in dimension means, take it as length here. 2 centimeter is change. 12 minus 10, that is 2 centimeter change agide. 2 centimeter. Initial, original length is 10 centimeter. 10 centimeter. Okay, strain produced is how much? 1 by 5. 1 by 5. Or how much? 0.2. 0.2. Okay, 0.2. Clear? 0.2 strain produced. ಅದೇ ಇನ್ನೊಂದು ಕೇಸ್ ಕನ್ಸಿಡರ್ ಮಾಡಿ. Initially having the length 10 centimeter. Rubber band has the initial length how much? 10 centimeter. When you stretch it, its length becomes how much? Okay, take it as 14 centimeter. 14 centimeter. Now strain produced, strain ಎಷ್ಟಾಗಿದೆ? Strain is equal to change in dimension to the original dimension. Change ಎಷ್ಟಾಗಿದೆ? 14 centimeter minus 10 centimeter. How much? 4 centimeter. 4 centimeter is the change in dimension. 4 centimeter. And initial dimension, original dimension, length of the rubber band is 10 centimeter. How much value? It is 0.4. Strain is, now the strain value is 0.4. Okay, previous case ಅಲ್ಲಿ ಎಷ್ಟಿತ್ತು strain value? 0.2. Carefully note ಮಾಡಿ. Initially the rubber band has the length 10 centimeter. When you stretch it, its length changed. The length of the rubber band is now 12 centimeter. Okay, when you stretch more, when you stretch it more, the length again increased. Now the length of the rubber band is 14 centimeter. Okay, now in this case strain is 0.4. So in which case the strain value is more? In this case the strain value is more. So strain is more means deformation is more. Deformation is more. Illi adra initial length ಗಿದೆ deformation ಜಾಸ್ತಿ ಆಗಿದೆ. Deformation means change in the shape or size. Change in the shape or size of the object. Okay, deformation ಯಾವುದ್ರಲ್ಲಿ ಜಾಸ್ತಿ ಆಗಿದೆ? In the second case ಅಲ್ಲಿ. So strain tells us the how much deformation occurs. Okay, if the strain is more, deformation is more. Okay, what is the strain? It is the ratio of change in dimension to the original dimension. Original dimension. ಅಥವಾ ಹೇಗೆ ಹೇಳ್ಬೋದು? It is the change in shape or size due to the deforming force. Okay, ಆ deforming force ಇಂದ shape or size of the body ಎಷ್ಟು change ಆಗಿದೆ ಹೇಳೋದನ್ನ ಏನು ಹೇಳೋದು ನಾವು? Strain. We call it as strain. Okay, there are 3 types of strain we know. 3 types of strain. Three types of strain. 1. So we know the 3 types of stress: longitudinal, tangential, volume. Same way strain: longitudinal strain, tangential strain, or shearing strain. Third one, hydraulic or bulk or volume strain, volume, strain. Okay, there are three types of strain. First one, consider which strain? Longitudinal strain. First strain, type of strain is longitudinal strain. Okay, what is longitudinal strain? We know the longitudinal stress. So, longitudinal strain means if the deforming force produces a change in the length, then the strain is produced is called as longitudinal strain. What is longitudinal strain? If the deforming force produces change in the length, deforming force produces change in the length. Take it as example of rubber band or spring ತಗೊಳ್ಳಿ. So load apply ಮಾಡಿದಾಗ, force apply ಮಾಡಿದಾಗ its length changes. Deforming force changes its length. If the deforming force changes its length, then the strain produced is called longitudinal strain. Or also it is defined as, ಹೇಗೆ ಹೇಳ್ಬೋದು, change in dimension means here longitudinal strain is defined as the ratio of change in length to the original length. Okay, what is longitudinal strain? Longitudinal strain is the ratio of change in length to the original length. Okay. So strain produced when the length of the object changes is called longitudinal strain. It is the ratio of change in length to the original length. Strain is nothing but change in dimension to original dimension. In the case of longitudinal strain, change in length to original length. Clear? Consider if the body having the initial length L, its length increases. Okay, whatever the body, the rubber band anta ಕೊಳ್ಳಿ, its length increases by del x, then the longitudinal strain in this case change in length is delta x, and original length is L. Okay, this is longitudinal strain, delta x by L. Okay, change in length to original length. Clear? Yes. Next, which type of strain? Tangential or shearing strain. Second type is shearing or tangential strain. What is shearing or tangential strain? Yes, if the deforming force produces change in the shape of the body, then the strain is called as shearing or tangential strain. Okay, if the deforming force produces change in the shape of the body, then the strain is called as tangential or shearing strain, and it is also defined as the ratio of relative displacement to the length of the object. Okay, length of the object. Okay, so example nodi, we know that if the book is placed on the table, what happens when you push the top surface, its shape changes. Bottom surface fixed. Now imagine bottom surface is fixed. One surface is ಏನಾಗಿದೆ push ಮಾಡಿದ್ದೇವೆ. Now the shape of the book is changed. Initially it is in rectangle, now it is in, just imagine it is in parallelogram. Now the shape of the book is body is changed. So here relative displacement of this plane relative to the fixed plane, that is delta x, and length of the object, take it as L, length of the object is L. Now the relative displacement is delta x. Now shearing strain is equal to shearing strain is equal to ratio of relative displacement, how much, delta x, to the length of the object, what is the length, L. Okay, here theta is the angle, take it as theta is the angle. If theta is the angle, opposite by adjacent, this is nothing but what, opposite by adjacent, which angle, tan theta, this is tan theta, right? Tan theta is equal to how much, or delta x by L, okay, delta x by L. Clear? Shearing strain or tangential strain. So if the deforming force produces a change in the shape of the body, then the strain is called as shearing or tangential strain, and it is also known as the ratio of relative displacement of the plane with respect to fixed plane, relative displacement to the length of the object, here delta x by L is nothing but tan theta. Tan theta is equal to delta x by L. Clear? Yes. Next, which type of strain? Yes, longitudinal, tangential or shearing strain. Third one, volume strain. Yes, volume or hydraulic or bulk strain. Okay, what is volume strain? If the deforming force produces change in the volume of the body, then the strain is called as volume strain. Okay, deforming force produces change in the volume of the body, then the strain is called volume strain, and it is also defined as the ratio of change in volume to original volume, right? Original volume. Okay, volume strain is the ratio of change in volume to the original volume. Okay, volume strain. If delta V is the change in volume and V is the original volume, then volume strain is given as delta V by V. If delta V is the change in volume and V is the original volume strain is given by delta V by V. Simple, right? Yes. Clear? Yes. Mechanical properties of solids. In that, we studied about the concept what? Elasticity, plasticity, elastic body, plastic body, stress, 3 types of stress, strain, 3 types of strain, right? Okay, next we will move on to the concept that is Hooke's law. Very important law, Hooke's law. See, these are the concepts covered. Next, Hooke's law. Okay. Hooke's law. It states that within the elastic limit, stress is directly proportional to strain. Hooke's law states that what? Within, very important law, within the elastic limit, stress is directly proportional to strain. Stress is directly proportional to strain. Okay, directly proportional to strain. Hooke's law states that what? Within the elastic limit, stress is directly proportional to strain. Statement है कि stress directly proportional to strain. Stress proportionality constant degree K into strain. K is equal to stress by strain. Okay, K is equal to stress by strain, where K is the proportionality constant or constant of proportionality constant called modulus of elasticity, or called as what? Modulus of elasticity. Modulus of elasticity. Okay, clear? Stress is directly proportional to strain, proportionality constant, where K is the proportionality constant. K is equal to stress by strain. Okay, within the elastic limit, what is elastic limit? What is elastic limit? It is the upper limit of the deforming force. Elastic limit is the upper limit of the deforming force for which the body regains its original shape and size. Okay, what is elastic limit? It is the upper limit of the deforming force. Upper limit of the deforming force for which body regains its original dimension. Or original shape or size. Regains its original shape or size. Okay, for example, consider the spring. Okay, consider the spring. We are applying the external force load apply ಮಾಡ್ತಾ ಇರ್ತೇವೆ. Okay, so when we remove, for example, first 50 gram apply ಮಾಡಿದ್ವಿ, 50 gram. Okay, when applied 50 gram, when we remove the 50 gram, it comes to its original position, it comes to its original dimension, shape ಗೆ ಬರುತ್ತೆ. Apply 100 gram load, again when you remove the 100 gram load, it comes to its original dimension. Apply 200 gram, it comes to its original dimension. So up to its elastic limit, take it as 500 gram. Just imagine its limit is 500 gram. So ಈಗ ನಾವು 500 ಅಂದರೆ 501 gram ಹಾಕಿದ್ದೇವೆ, 501 gram load ಹಾಕಿದ್ದೇವೆ. Now when we remove this 501 gram load, it does not comes to its original shape. Again ಅದು original shape ಗೆ ಬರೋದಿಲ್ಲ. Okay, it loses its elasticity, and it is permanently deformed. Okay, ಅದಕ್ಕೂ ಮೀರಿ ನಾವು ಡಿಫಾರ್ಮಿಂಗ್ ಫೋರ್ಸ್ ಹಾಕಿದ್ರೆ ಏನಾಗುತ್ತೆ, ಅದು elastic limit ಅನ್ನ ಕ್ರಾಸ್ ಆಗಿರುತ್ತೆ. So it does not regains its original shape and size. It is permanently deformed. Okay, this is elastic limit. It is the upper upper limit of the deforming force for which body regains its original shape or size or original dimension. Clear? Yes. So Hooke's law ಏನು ಹೇಳುತ್ತೆ? Within the elastic limit, stress is directly proportional to strain. ಅದೇ. So within the elastic limit, ಇಲ್ಲಿ 500 ಗ್ರಾಮ್ ಅಂತ ಹೇಳುವ. Within the elastic limit up to 499 gram, stress is directly proportional to strain ಅಂತ ಹೇಳ್ಬೋದು. Stress is directly proportional to strain. How? For example, if you apply 50 gram external load 50 gram ಹಾಕಿದ್ದೀರಿ, ಈ ಕೇಸಲ್ಲಿ 2 centimeter stretch ಆಯಿತು, strain produced 2 centimeter, just imagine. And when you apply 100 gram strain ಈಗ 4 centimeter, change in the length is 4 centimeter. When you apply 150 gram, change in the length is 6 centimeter. Okay, length proportionally increase ಆಗ್ತಿದೆ. So within the up to 450 490 ತನಕ ಏನಾಗುತ್ತೆ, ಎಷ್ಟು ಲೋಡ್ ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತೆ, ಸ್ಟ್ರೈನ್ ಅಷ್ಟೇ ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತೆ. Clear? So within the elastic limit, stress is directly proportional to strain. Okay, this is the statement of Hooke's law. So using this Hooke's law, we can draw stress strain curve. See, stress strain curve. See, draw the stress along y-axis and strain along x-axis. Okay. So the curve is like this. O, A, B, C, D, E. Mark the points. It is permanent set and the okay, this is stress Newton per meter square. See the curve, stress strain curve like this. Stress along the y-axis, strain along the x-axis. So the curve A, B, C, D, E points. This is permanent set. This is sigma y, sigma u. This curve is like this. So from the curve, see here, from the region O to A, in the curve region O to A, stress is proportional to strain. As the stress increases, strain also increases. So up to 0 to A, in the region O to A, stress is directly proportional to strain and it obeys Hooke's law. According to Hooke's law, within the elastic limit, stress is directly proportional to strain. It obeys Hooke's law and the body regains its original shape after the removal of deforming force. Okay, the body in this region, the body regains its original shape after removal of deforming force. Okay, And from the region A to B, stress and strain are not proportional. Stress and strain not proportional, but still the body regains its original shape. Body regains its original shape after the removal of deforming force, and here B is called the yield point. Or elastic limit. And the corresponding stress value is called as yield strength. Corresponding stress value is called as what? Yield strength. Okay, that is sigma y. Okay. If the load is increased further, what happens? The stress exceeds the yield strength, and the strain increases rapidly even for the small value of stress, for the small change in stress. This is represented by the curve or the region BD, between the region BD. Okay, what happens? Clearly see here, ಏನಾಗುತ್ತೆ first ಈ region 0 to O to A represent that, stress is directly proportional to strain. It obeys Hooke's law, and the body regains its original shape, original dimension after removal of external force. See, if consider the spring, when you apply the load, what happens? Stress 50 gram ge 2 centimeters stretch aitu body spring. For 100 gram increase in length is 4 centimeter. For 150 gram increase in length is 6 centimeter. For 200 gram increase in length is 8 centimeter. Just imagine. So here stress is directly proportional to strain. Okay, as the stress increases, strain also increases in the region what? O to A. Clear? If we remove this external force, body comes to its original shape. Remove this external force, body comes to its original shape. Okay. Next, in the region, this region is clear? Yes. From A to B, region A to B, stress is not proportional to strain. Okay. ಅದೆಲ್ಲಿ ಹೇಗೆ ಅಬ್ಸರ್ವ್ ಮಾಡ್ಬೋದು? Stress is not proportional to strain means, so here when you apply 200 gram, strain may be 10 cm, andre change in length is 10 centimeter. When you apply 250 gram, change in length may be 13 centimeter. Okay, when you apply 300 gram load, external force, change in length is 14 centimeter. Here the change in length is different, right? So here the strain is not same. Stress is not proportional to strain. But the body still regains its original shape and size after removal of external force. When we remove the external force, what happens? The body regains its original shape or original dimension. It comes to its original dimension when we remove the external force. So up to which limit? Up to B, up to point B. stress value be. This point is called yield point or elastic limit. Elastic limit, after which body does not regain its original shape or original dimension. Okay, the stress value corresponding to this value is called as what? Yield strength. Yield strength. Clear? Yes. If the load is increased further, okay, now take it as 300 gram is the elastic limit value. 300 gram is the elastic limit value. If the load is increased further, what happens? What happens if the load is increased further? Yield strength exceeds the stress value. The strain increases rapidly. Okay, if the stress increased 300 gram idadu 310 gram, when we apply, if the load increased, what happens? Strain increases rapidly. Strain increases rapidly even for the small change in the stress. Even for the small change in the stress, even we increase the stress value, small 310 gram hakidru strain value is more. Strain value is more. Okay, means change in length is more. Here for 300 gram it is 14 centimeter. 14 centimeter. When you apply 320 gram, the strain produced, change in length may be 17 centimeter. 17 centimeter. Okay, 17 centimeter. Okay, if you increase the load further, what happens? Strain value is increases rapidly even for the small value of stress. Okay, from the region, see here, consider from the region between B to D. Consider the point C. Consider a point C for which the stress value, stress, even if the stress value is 0, strain is not 0. Even the stress value is 0, strain is not 0. Okay, now the material is said to have permanent set. The material is said to have permanent set, and the deformation is plastic deformation. Plastic deformation. See here, now the point is after, beyond this, what? Yield point, elastic limit. What happens? The body does not regain its original dimension. Consider point C. The body, when you remove the external force, what happens? Body does not regain its original dimension. See here, 320, 330 maybe, if you apply the force, load 330 gram, elongation produced may be 20 centimeter. So the change in length may be 20 centimeter. When you remove this 330 gram, it does not comes to its original dimension. Okay, the body does not comes to its original dimension. So now the elastic behavior is lost. Elastic behavior of the material is lost. Okay, this is called as permanent set. This behavior is called as what? Permanent set, or the body is now permanently, plastic deformation, undergoes plastic deformation. So here D, point D is called the ultimate tensile strength. Ultimate tensile strength of the material. Ultimate tensile strength of the material. E is the fracture point. Okay, so up to ultimate strength, even for the, this is the ultimate strength of the material, so that we can give external force to that material. We can give the external force to the material. After this ultimate strength, Just imagine the ultimate strength of the body, maybe 700 grams. 700 grams. 700 gram. What happens? So when we apply 701 gram, what happens? So ultimate strength, it fractures, it breaks down. What happens? It breaks down. Okay, this point is called a fracture point or breaking point or a breaking point. Breaking point. Okay, this is stress strain curve. If D and E are close to each other, if the point D and E is close to each other, then the material is called brittle. Brittle. If the point D and E far away from each other, then the material is called ductile. Okay. If D and E is close andre ಏನು, so ultimate strength ಆ ಮೆಟೀರಿಯಲ್ ಇದು, ಆ ಸ್ಪ್ರಿಂಗ್ ಇದು ultimate strength ಗೆ ರೀಚ್ ಆಗಿದೆ. ಸೊ 700 is the ultimate strength. 700 ಗ್ರಾಮ್ ಅಷ್ಟು ಹಾಕ್ಬೋದು ನಾವೀಗ 701 ಗ್ರಾಮ್ ಹಾಕಿದ್ದೇವೆ. ಆಗಲೇ ಆ ಸ್ಪ್ರಿಂಗ್ ಕಟ್ ಆದರೆ, ಬ್ರೇಕ್ ಆದರೆ ಅದರ ಫ್ರ್ಯಾಕ್ಚರ್ ಪಾಯಿಂಟ್ ಆಯಿತು. ಬ್ರಿಟ್ಟಲ್, ಇಟ್ ಈಸ್ ಬ್ರಿಟ್ಟಲ್ ಅಂದರೆ it is easily breakable material. If the length region from D to E is away from each other, then the material is ductile. Means what? 700 is the ultimate strength. 700 gram is the ultimate strength of the body. And now innu ಒಂದು 750 gram ಹಾಕಿದ್ವಿ. Again it elongates. ಏನಾಗುತ್ತೆ? Elongates ಆಗುತ್ತೆ. And again 800 gram ಆಗುತ್ತೆ. So up 800 gram, when we apply 800 gram of external force, now in this case the spring break ಆದರೆ, so it is ductile ಹೇಳ್ಬೋದು. Ductile. Okay, it is not easily breakable. Ductile. Okay, this is the stress strain curve. Explains the elastic behavior of the material. It is little bit confusing. ಸ್ವಲ್ಪ ಇನ್ನೊಮ್ಮೆ ಕ್ಲಿಯರ್ ಆಗಿ ಅದನ್ನು ಓದಿದ್ರೆ, ಗ್ರಾಫ್ ಆ್ಯಂಡ್ ಅದರ ವ್ಯಾಲ್ಯೂ ಜಸ್ಟ್ ಥಿಂಕ್ ಮಾಡಿ ಅಗೇನ್ ಓದಿದ್ರೆ ನಿಮಗೆ ಕ್ಲಿಯರ್ ಆಗಿ ಅರ್ಥ ಆಗುತ್ತೆ. ಸೊ ಈಸಿಯಾಗಿ ಅರ್ಥ ಆಗಬೇಕಾದ್ರೆ ಗ್ರಾಫನ್ನು ಆ್ಯಂಡ್ ಸ್ಟ್ರೆಸ್ ಅಂದ್ರೇನು, ಸ್ಟ್ರೈನ್ ಅಂದ್ರೇನು ಕ್ಲಿಯರ್ ಆಗಿ ಗೊತ್ತಿರಬೇಕು. ಹುಕ್ಸ್ ಲಾ ಅಂದ್ರೇನು, ಇಲಾಸ್ಟಿಕ್ ಲಿಮಿಟ್ ಅಂದ್ರೇನು, ಸ್ಟ್ರೆಂತ್ ಅಂದ್ರೇನು, ಮೆಟೀರಿಯಲ್ಸ್ ಪ್ರಾಪರ್ಟಿ ಇದೆಲ್ಲ ಗೊತ್ತಿದ್ರೆ ನಿಮಗೆ ಈ ಗ್ರಾಫ್ ಈಸಿಲಿ ಯು ಕ್ಯಾನ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್. ಅದರ್ವೈಸ್ ಇಟ್ ಈಸ್ ಡಿಫಿಕಲ್ಟ್ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ದಿಸ್ ಗ್ರಾಫ್. ಓಕೆ, ಸೊ ದಿಸ್ ಈಸ್ ದ ಸ್ಟ್ರೆಸ್ ಸ್ಟ್ರೈನ್ graph curve. Okay, this is the mechanical properties of solids in the chapter. What is elasticity, plasticity, stress 3 types, strain 3 types, Hooke's law and stress strain curve. Okay, very important chapter. Okay, thank you. All this